What in the world are you doing?
Polly want a cracker?
Polly want a cracker? And they're like, this is not a biology class.
Polly want a cracker?
Polly want a cracker. Well, I guess, Mr. Sams, we are going to be talking about how polyatomic ions work. So maybe that's the polyatomic ion thing. Okay, it's getting annoying already. People, is it annoying to use what? Is it to me? Yeah, okay.
Probably not as annoying as the crazy accents that, you know.
Hey, what you talk about that, Mr. Sams? I think you're the crazy one. All right.
Yeah, that one.
Okay, so, hey, let's review. We're going to learn how to name some things and write formulas. We just did this, but we're going to do it kind of a little differently with polyatomic things with polyatomic ions. Remember the naming rules? You've already written these down. Here they are. You don't even probably need to push pause, but you use the exact same rules when you name them. So let's, name some things.
Okay.
Now, we do have an interesting thing here, don't we? We have polyatomic ions mixed in here.
Yeah.
Yeah, so let's talk about that. So let's look at calcium, or at CaOH2.
Is that calcium, perhaps, the Ca that you just divulged?
Yeah, I know, I divulged it. Yeah. Well, so we got Ca. So we kind of know that. Ca, of course, I don't need to look at that. So we've got Ca.
Which is calcium.
Calcium. We need to give him a last name. Now, when we give him a last name, we need to look at other polyatomic ions. Okay? I'm trying to find them. So calcium, and then we got that OH thing.
Yep.
What's up with the OH thing?
Well, we're going to have to look that one up.
Oh, and I happen to have that chart. Hey, you've got that copied down, or you've got it somewhere. And I see OH with a -1, and they say that its name is?
Hydroxide.
Hydroxide.
Now, where'd that -1 charge go on our compound there? Why isn't it there?
Well, because the charges have to add up to 0.
That's right. We don't write charges on the final compounds. So
yeah, so this is just calcium, and we just say hydroxide. Now, it's not like dihydroxide, as some people think, because there's 2 there.
No.
Actually, if you want to break that out, calcium, if you look on the periodic table, has a charge of 2, and each hydroxide, if you recall, was -1. And if you add those up, it's kind of like OH, -1. Well, -1 right here plus -1 is -2, and +2 adds up to 0. So that's why it's CaOH2. But we don't put a Roman numeral here because calcium.
It's not a transition.
It's not schizophrenic. No. Yeah. So, all right. What about this one?
Oh wow.
That looks really weird.
Cu. I know that's
all right.
copper.
Yeah. So that's copper. Good.
Now copper's a transition metal, so it's going to have to have a Roman numeral.
We'll have to do that Roman numeral game.
We'll have to do that later.
Well, C2H3O2. Let's look at our cool table. Oh, it's the one on the top.
Oh, look, they all go as a group. C2H3O2 go as a group.
That's one huge group.
So I don't
now,
have
how do you memorize acetate?
You
ever played football?
No.
Okay, well, when you're in football, they have like plays and stuff, right? And here's the play. Everybody say this, all right? And you're going to say this, right?
Okay.
Cho.
232. 232.
Negative.
Negative.
You got to say it like a football player, like whatever. Cho. 232. Negative. Say it now.
Cho. 232. Negative.
Do you get that? Cho. C-H-O. 232. Negative.
I see.
Yeah. So, anyways, that's acetate. Now, it has a -1 charge. All right. So his last name. Let's write that last name first.
Acetate. So I don't have to name the carbon and the hydrogen and the oxygen?
No,
They all go as a group.
This is one group. I like to put a square around it sometimes, and that's acetate right here. Now, we've got to give a Roman numeral because copper is a transition metal.
So what's the charge on acetate? We decided that was -1, right?
Yeah, it was -1. So there's only one copper, so you've got copper, and then you've got acetate. I'll just say AC with a -1 charge.
So copper has to be +1.
Has to be +1.
So the charge becomes the Roman numeral.
So it's Roman numeral 1.
All right.
Yeah. All right, how about this one? Oh, there's a... Now, CO is kind of a weird element. Some people get that confused with copper. It's not copper, it's
cobalt.
Cobalt.
And it's not big C, big O, because that would be carbon monoxide. It's big C, little o, which is the element cobalt.
And then PO4. Now let's look on our polyion list. Now you probably don't have these memorized, yes? I'm going to go to the page it happens to be on. I know it's on the 3rd page here, or the -3 column. So his name is phosphate. So phosphate is PO4 -3. All right.
So
PO4.
Phosphate.
So that's cobalt.
But
phosphate.
cobalt is a transition metal, isn't it?
Yeah, he's a transition metal. So we got to do.
So we need a Roman numeral.
A Roman numeral. So we got CO, CO, CO. And then we got PO4. You know, sometimes I think it's good to put a little box around it. And then PO4. Put a little box around it. And each of these has a charge of -3, which we just looked up on our table a minute ago. And so -3 plus -3 adds up to -6. So the charge of these 3 combined must be +6, because it always adds up to 0.
Yep.
So each cobalt would have...
It's going to be a +2.
Plus 2.
Because 2 and 2 and 2 is 6.
So this is cobalt 2. Now,
even though there's 3 of them, the Roman numeral is 2?
It seems weird. There are 3 of them, and the Roman numeral is 2.
Because the Roman numeral is always...
the charge! That's right. Okay, you got it. Yeah, Mr. Sam's, you're pretty good at this.
Thanks.
Yeah, I'm pretty impressed.
I've been doing it a while.
Yeah, you're pretty okay. You know, all right. All right.
All right.
Let's go the other direction.
Yeah, let's do.
Formula writing.
So we have the name. We need to go to the formula?
Yes, same rules.
Same rules.
Except we've got polyions.
And there's something about parentheses, right?
And there's something about parentheses. And we actually talk about use parentheses for any polyions. You wrote that down already, and now we're going to actually show you how it looks. Okay, sodium carbonate.
All right, I know sodium. That's Na.
So that's in.
And that's in the +1 column.
Because he's in the first column on the periodic table. Now remember, I like to make a little cheat sheet here, and I want to do this sodium and then carbonate. Okay.
Yep. Let's look that one up.
Now here is, all right, here's that charge.
-2. Yep.
It's not on that list, is it? Okay, you got to go to here.
Oh.
And there is carbonate right there, right? So carbonate is CO3 -2, right? So we have CO3 -2.
Now +1 and -2, that does not add up to
No,
0.
it doesn't. I think you need to have get the lowest common multiple. Actually, we didn't say this last time, but essentially what you're looking for is the lowest common multiple between 1 and 2, and that's pretty easy. It's 2. And so I need to get both of them to a charge of 2. And to do that, I need 2 sodiums. So Na +1, 1 and 1 here, adds up to +2, and of course -2 by itself is -2.
That adds up to 0.
0.
Which
so
is what we want.
it's Na2.
Na2.
So Na2, you need 2
There's
sodiums,
2 of them.
and then the CO3.
Notice
Now,
the charges are gone.
we should talk about parentheses here, Mr. Sams.
Okay.
Polyions, this is a group. CO3 has a charge of -2.
Yep.
But in this instance, there's only 1 carbonate, so we do not need parentheses.
If you have more than 1, that's when you start putting parentheses in.
Okay, yeah. And I think we'll see some of those. All right, copper 1. Ooh, there's a Roman numeral. What's that Roman numeral mean?
The charge.
So that'd be Cu.
That does not mean there's 1 copper.
In fact,
it's the charge.
There won't be.
No,
copper 1, +1, and phosphite.
Phosphite.
It's ite, and it's on the 3rd page here. If I can get there. Phosphite, here's this last one. PO3, -3. So you start to get to know these polyions as you start practicing and doing these worksheets. So phosphite is PO3, -3. Do those charges have 0?
No,
they do not. So what's the lowest common multiple between 1 and 3?
3.
So you need to get them both to 3. Well, the -3 is kind of already there. So I need to do Cu +1, Cu +1. So this will be Cu, Cu, Cu,
so
PO3.
Cu3.
We say Cu3, PO3. So that is the answer. Kind of weird that Cu3, PO3 is copper 1.
Because the
phosphite.
1 is the charge. It is not how many of them there are.
All right, well, let's do another one. Copper 2 phosphite. Well, I think we should do a different page. I think we're going to need some more space for copper 2 phosphite. So let's just have a blank page. Copper still is Cu. Now, it said for copper 2.
So it's a +2 charge.
So it's +2. In phosphite, it was still that PO3 -3. Now, you might want to put a little box around that, a little square, and say that whole box has a charge of -3. Now, I need to get them to, well, they don't add up to 0, and it's not like I just add 1.
Common multiple of 2 and 3 is 6.
6, so I need to get them both to 6. So I can have another box, and that will have a -3 charge. Of course, in that box is PO3.
Okay, so that's -6.
So this adds up to -6.
Yep.
And then here, to get to copper to 6, I'll need 2 additional coppers, right?
Uh-huh.
And that adds up to +6. Of course, you add those buggers together, and
you get 0.
You get 0. So I need 3 coppers and 2 boxes.
Yep. So Cu3.
Cu3.
All right. Now.
PO3. 2.
PO3.
2, because I got just 2 boxes.
No, but it's PO3 is the phosphite. You cannot change that.
Yeah, it's PO3, and now this is
where I need 2 of them, so we put it in parentheses.
Yeah, so you guys, it's important to notice that here you need 2 full boxes, and in a box there's a P and 3 O's, and so it's kind of scribbly. It's Cu3. I'm going to write it better. PO3 2. That is the formula of copper 2 phosphite. I know it's odd. There's a 3 there, and you want to say there's no, because the Roman numeral is the charge. Charge. Okay.
I think that's it.
I think there's no more, so I think you guys get it. You're going to do lots of practice.
Lots.
And you'll be good. Really good. Well, you're already good anyways, but you'll be better. Yeah. All right. Great.